All right,
Okay.
so I am here with Allie, and we are going to work number 7 on her section 8.7, which has to do with finding the error or finding the number of subintervals you need in order to get within a certain error using either the trapezoid or the Simpson's rule. So the trick with these problems is applying this theorem, which is like for trapezoid rule, if the second derivative of the function, so in this case, this is your f, 4 divided by s squared ds, that's your f.
Okay.
We have to look at the second derivative of it, and as long as it's continuous and we can find an upper value for it, for the absolute value of it on the interval from a to b, which in this case our interval is from 1 to 2, then we have this equation for the error that we can plug in all the different pieces and solve for n in order to get that.
Okay.
So the first thing you do is take your function 4 divided by s squared, and I just like to rewrite it as 4s to the negative 2.
Okay.
And then we'll take our first derivative, which will be negative 8s to the negative 3. And then our second derivative will be 24s to the negative 4.
Yes.
So if you look at that, if you look at a graph of 24 over s to the negative 4, it just kind of looks like, you know, it sort of has 2 branches. Now we're only concerned on the interval from 1 to 2. So we're only looking at it, like here's our x from 1 to 2. So we're only looking at it kind of this little piece right here. And you can see that that function is continuous and always decreasing on the interval from 1 to 2. So its maximum is going to occur at 1 because it's decreasing. Does that make sense?
Yes, yes.
Okay. So we'll figure out what that value is. If we plug 1 in, we get, of course, just 24. So that is our second derivative, which in this number then is our m that we're going to use in the formula. So that's our m. So now we'll take this formula for the error. We'll say 10 to the negative 3 is equal to 24 times 2 minus 1 cubed, because b minus a is, you know, b is 2 here and a is 1. And we'll divide by 12n squared. And obviously we're trying to solve for the number of subintervals. So we're trying to solve for n.
Yes.
So, you know, you just do a little algebra here, and then be careful when you're typing this into your calculator. If you do it that way, you want to make sure your denominator is in parentheses because you have that product there.
Okay.
And then when you type it in, you should get 45.
Okay. Okay.
So the Simpson's rule will be similar, except that you need a fourth derivative. So your second derivative was 24s to the negative 4. So your third derivative is going to be 24 times 4. And then, so 96, negative 96 s to the negative 5. And then your fourth derivative is 96 times 5, which is 480. 480 s to the negative 6, which if you need to, you can graph that, but it'll actually look very similar to the 24s to the negative 4. It's just that it's going to be, you know, different y values, but the shape of the graph is going to be similar. So it's going to have a max at 480 also, because it's going to be decreasing over the interval. And when you plug 1 in, you'll get the max will be at s equals 1. So it'll be 480. So now your formula is a little bit different. You're going to do the error here. We also want to be with 10 to the negative 3, less than or equal to. Now we'll have 480. B minus a is still 2 minus 1, so that's going to be just 1 to the 5th divided by, now it's 180 n to the 4th, right?
Mm-hmm.
So you're going to do n will be equal to the 4th root of 480 divided by 180 times 10 to the negative 3.
Okay.
And you have to, if your answer is odd, you have to round up to the next even integer, because the Simpson rule requires that you have even integers. So we can type this in to our calculator. So to do a fourth root, you can just do, so you'll do 480, just do this in parentheses, divided by, make sure this is in parentheses, 180 times 10 to the negative 3. And then you're going to raise that to the fourth root. So you put this, you do 1 divided by 4 in parentheses in the exponent, like that.
Okay. Okay.
And then that gives you 7.18, but it always has to be an even number, and you want to round up to the next even number. So in that case, it would be 70. 7.1. It would be 8. Would be the next.
So it would just be like 8.0. Or just 8.
Right. Well, because it's the number of subintervals, so it's just an integer.
Okay. Okay. Yes, that makes sense.
Okay. So let me stop that recording.